problematic mathematical oriented paper. Once again, good morning to all. Myself, Dayanidhi, Assistant Professor, Hero Secondary Engineering College. I am going to handle finite element analysis for great prerana for higher studies of UG students. So, in this subject, Introduction to Finite Element Analysis, we need to discuss about finite element method and finite element analysis. So, in that we have two methods. One is weighted residual method. Another one is Rayleigh-Rich method. See, what is finite element analysis? The finite element method is a numeric. Already we discussed these things. Once again, you need to listen. The finite element method is a numerical technique for finding approximate solution to boundary value problems for differential equations. In simple terms, FEM is method of dividing up a very complicated problem into small elements that can be solved in relation to each other. Useful for problems with complicated geometries, loadings, and material properties where analytical solution cannot be obtained. So, where the analytical solution we can't obtain for in that places, we need to use finite element analysis. We know three type of analysis. One is analytical method, another one is numerical method. So FEA comes under numeric experimental, analytical, and numerical methods. We know very well. In that experiment method, we need to do practically. Then we will compare with exact solution. Then analytical method, we need to drop a graph. In that from diagrams, graph, we will get the values, comparison of original value. That is called analytical method. Third one is numerical. In that numerical method, that is out of numerical method, the finite element analysis and finite element methods, it will come under that category. So in that we need to use linear approximation and quadrilateral approximation. Okay, how does finite element analysis works? FEA uses a complex system of points called nodes, which make grid called a mesh. Okay. In this mesh is programmed to contain the material and structural properties which define how the structure will react to certain loading conditions. That means in a structure we need to split n number of elements. In that single element having properties like displacement or temperature or any distribution. From that particular element, we are finding all the properties. Using that, we are calculating total structural property. That is how we will get means from global finite element equations. Okay, nodes are assigned at a certain density throughout the material depending upon the anticipated stress levels of particular area. Regions which will receive large amount of stresses usually have a higher node density than those which experience a little or no stress. Points of interest Points of interest may consist of fracture point of previously tested material, fillets, corners, complex detail, and high stress areas. This mesh act as like a spider web in that from each node there extends a mesh element to each of the adjacent nodes. This web vectors is what carries that material properties to the object, creating many elements. We know the general steps of FEA. First one, we need to recall now because 1 week is over, so we forgot it. We need to recall general steps of FEA. First one, what all of us very well we know. First step is discretization of the structure. That means the art of subdividing the structure into convenient number of smaller element. This is called discretization. What are the elements available? One dimensional element, two dimensional element, three dimensional element, and four three dimensional. One dimensional elements are called bar element, beam element. Two dimensional elements are called. Anybody can you say what are the elements? Two dimensional elements?
Sir,
Anyone?
triangular, rectangular.
Okay, okay, pa. This is for gate video, so listen carefully. Okay, then problems we'll discuss in next classes. I think in slide share I will show all those things. Just listen carefully. If I ask question, answer me properly. Okay. Triangular and rectangular elements like that. Okay, there's a step two is numbering of nodes and elements. Can you anybody say what are the methods available for numbering of nodes and elements?
Long side method, short side method.
Longer side numbering process, shorter side numbering
Longer side,
process. by using the formula, maximum number minus minimum number should be equal to maximum known number minus minimum known number should be equal to minimum. Okay, so by using shorter side numbering process, it will be very useful to find the sorry, very be useful to give the numbers to the nodes and elements. Okay, this is step two. Okay, next next third step. What is the third step? Anybody can you say now? Third step.
Selection of a displacement function.
Wait. Selection of displacement function or interpolation function. Using linear or quadratic equation, we are defining the function, defining the displacement function or force function, because we have only two methods, one is displacement or force. So in the displacement function in linear means a naught plus a1x plus a2y, like that. There is no cubic orders, so that is called linear equations. So that a naught, a1, a2, these are constants, we need to find these values. Okay, same like that, a naught plus a1x plus a2x squared plus a3y plus a4x y squared, like that it will go continuously in that higher order equations, means that is called as quadratic equation. Okay, so mostly we are using in finite element analysis linear equations only, dy by d squared dx, dy by dx or d squared y by dx squared, like that. Okay, this up to three steps we discussed. Now, what is types of engineering analysis? Structural analysis. Structural analysis consists of linear and non-linear models. Linear models use simple parameters and assume that material is not plastically deformed. Non-linear modes consist of stressing the materials post in elastic capabilities. The stresses in the material then vary with the amount of deformation. Vibration analysis, already we discussed in structural problems, vibration problems, dynamics problems, we are going to use FEA. Here vibration analysis, it is used to test a material against strength of vibrations, shock and impact. Each of these incidents may act on the natural vibrational frequency of the material, which in turn may cause resonance and subsequent failures. Okay, this it will be very useful for design of machine elements problems. Okay, it's in higher studies, it will related to design problems. Okay, fatigue analysis. Fatigue analysis helps designers to predict the life of a material or structure by showing the effects of cyclic loading on the specimen. Okay, cyclic loading, the term it will comes under fatigue. Okay, such analysis can show the areas where crack propagation is most likely to occur. Failure due to fatigue may also show the damage tolerance of the material. See the diagram, analysis of fatigue in frames of a locomotive. Heat transfer analysis. Heat transfer analysis models the conductivity or thermal fluid dynamics of a material or structure. This may consist of a steady state or transient transfer. Steady state transfer refers to constant thermal properties in the material that yield linear heat distribution. Thermal analysis of shell and tube heat exchanger. See the diagram. Okay, how can the FEM help the design engineer? The FEM offers many important advantages of the design engineer. Easily applied to the complex, irregular shaped objects composed of several different materials and having complex boundary conditions. Applicable to safety state, time independent, and eigenvalue problems. Already we discussed, we know very well eigenvalue, eigenvector. All of you know very well because we studied in algebra, linear algebra. Applicable to linear and nonlinear problems. One method can solve a wide variety of problems, including problems in solid mechanics and fluid mechanics, chemical reactions, electromagnetics, biomechanics, heat transfer, and acoustics, to name a few. How can the FEM help the design organization? Simulation using FEM also offers important business advantages to the design organization. reduced testing and redesign cost, thereby shortening the product development time. Identify issues in designs before tooling is committed. Refine components before dependencies to other components probe changes. Optimize performance before prototyping. Discover design problems before litigation. Basic steps and phases involved in FEA already we discussed. Can you carefully read out, or I'll read out now? Discretization, we know that very well. Second one, what is the second step? Numbering of nodes and element. Third one, selection of approximation function. That means linear or interpolation function. Fourth one, fourth step. Anybody can you say derive the? Anyone say? Can you say derive the step four?
Material behavior by using
Derive the material by using displacement function and stress strain function.
sustained relationship.
Okay, very good. E is equal to du by dx, u2 minus u1 by x2 minus x1. So stress equal to young's modulus into strain. So using that equation, we are solving, we are defining the material behavior. Fifth step, derive the element stiffness matrix into global equations. F equal to K into U. Force matrix equal to stiffness matrix into force matrix into திரும்பி வாங்குறியா ஏன் force matrix equal to stiffness matrix into displacement matrix into stiffness matrix. Okay, this is the fifth step. Sixth step, assembling of element stiffness matrix into global equation. Assembling of element stiffness matrix into global equation. This is sixth step. What is the seventh step? Anybody can you say what is the seventh step?
Applying boundary condition.
Boundary conditions. I told already, if the beam is fixed means there is no displacement. That means if the point one means u1 displacement is zero. Okay, and like that we can say eighth step. Step seven, apply boundary condition. Eight. Step eight.
Solution for the unknown displacement.
Very good. Solution of the unknown displacement by using Gauss elimination method or Gauss Seidel method. We are finding the unknown values like A1 and A2 values. Okay, that is called eighth step. Ninth step, compute the eighth step.
Of the
Computing of the
element strains and stresses
strain
from
and
the
stress
model
in the
displacements.
Okay, very good. And the same equation like fourth one, define the material bigger by using the same equation we are solving in ninth step. Tenth step is interpolation of the results. That means post processing. Okay, these are the 10 steps we are following here. The same equations they are given: formation of element stiffness matrix, formation of total stiffness matrix, formation of element loading matrix, formation of total loading matrix, formation of overall equilibrium equation, implementation of boundary conditions. அவசரப்படாத, அது ஹெட் ஆஃப் த டிபார்ட்மெண்ட் கையில வச்சு சூப்பர்வைசர் அம்மன். சொன்னல, இதுதான் புதுசு இல்ல. Implementation of boundary condition, calculation of unknown nodal displacement, calculation of stresses and strains. Then see, I told already pre-processing, solution, post-processing. Here the final element mesh is developed to divide the given geometry into subdomains for mathematical analysis and the material properties are applied to and also boundary conditions solution. The space governing matrix equations are derived and the solution for the primary quantities is generated. Post processing. In the last phase, checking of the validity of the solution generated, examination of the values of primary quantities such as displacement and stresses, errors involved it carried out. Advantages of FEA. Advantages of finite element analysis can readily handle complex geometry, can handle complex analysis types like vibration, heat transfer, fluids, etc. Can handle complex loading, node based loading, element based loading, time or frequency dependent loading. It can handle complex restraints, indeterminate structures can be analyzed, can handle bodies comprised of non-homogeneous materials, can handle bodies comprised of non-isotropic materials, example orthotropic and anisotropic. Special material effects are handled such as temperature dependent properties, plasticity, creep, swelling, etc. Special material effects are handled such as temperature dependent properties such as temperature dependent properties, plasticity, creep, and swelling. கேட்டுக்கோங்க சரி சார் நான் தோணு முடிச்ச போகணும் can handle bodies comprised of non-homogeneous materials, can handle bodies comprised of non-isotropic materials, orthotropic and anisotropic. Special material effects are handled such as temperature-dependent properties, plasticity, creep, and swelling, etc. Disadvantages of FEA. A specific numerical result is obtained for a specific problem. The Findelman method is applied on an approximation of the mathematical model of a system, the source of so-called inherited errors. Experience and judgment are needed in order to construct a good finite element model. A powerful computer and reliable FEM software are essential. Input and output data may be large and tedious to prepare and interpret. Numerical errors such as limitation of the number of significant digits, rounding off occur very often. Fluid elements with boundaries at infinity can be computed and treated by using boundary element method. Software packages of FEA. ANSYS, Nastron, Patron, NISA, Display Tree, LS Dyna, Hypermesh, CATIA, ProE, SolidWorks, and Cosmos. These are all called softwares or FEA softwares. Once again, I'll repeat you. ANSYS, Nastron, Patron, NISA, Display 3, LS Dyna, Hypermesh, CATIA, ProE, SolidWorks, and Cosmos. These are all the called software packages of FEA. ANSYS, Nastron, Patron, Nishot, LS Dyna, Hypermesh, CATIA, ProE, SolidWorks, Cosmos. Okay, we'll move to the problem. Carefully listen. Okay, listen. I think last class d squared by dx squared plus 500 x squared equal to 0, 0 less than or equal to, it's zoom it, you can see very clearly, just zoom it the screen, you can see very clearly the differential equation of physical phenomenon is given by d squared I by dx squared plus 500 x squared equal to 0, 0 less than or equal to x less than or equal to 1, trial function equal to y equal to a1 into x minus x power 4. Boundary conditions are y of 0 equal to 0, y of 1 equal to 0. We know very well this problem because y is equal to a1 into x minus x power 4. I told last class in Google Classroom you need to submit. In this video, y of 0 equal to 0, y of 1 equal to 0. We have four methods we know very well: point collocation, subdomain collocation, least square, and Galerkin method. Y is y is equal to a1 into x minus x power 4. X equal to 0, we can put y equal to 0. X equal to 1, y equal to 0. Okay, we know very well y equal to a1 into x minus x power 4 dy by dx. We can say a1 x. We need to differentiate with respect to x. We will get 1 x power 4. While doing differentiation about x with respect to x power 4, x power n equal to nx power n minus 1. So we can say 4x cube. X power 4 on 4x cube. Okay, a1 again we are going to differentiate d squared I by dx squared. A1 x we will differentiate, will get 0. 4x cube will differentiate 12x squared. So d squared by dx squared we can write minus 12 a1 x squared. So substitute this d squared. What is residue? We need to substitute that d squared x by x d squared by dx squared value into that main question. So we'll get minus 12 a1 x squared plus 500 x squared equal to residue. So residue should be 0 in where we can say 0 in point collocation method. So x equal to 0 to 1 limit. So we will get we need to get x squared value. From that only we can get x value. For that purpose we are using 0 to 1, we are using 1 by 2 minus 12a1 into 1 by 2 whole square plus 500 1 by 2 whole square equal to 0. Minus 12a1 into 1 by 2 whole square we can say 1 by 4 plus 500 1 by 2 whole square we can say 1 by 4 equal to 0. Minus 3a1 plus 125 equal to 0. We can say a1 equal to 41.66. So I equal to 41.66 in minus x power 4. Again, subdomain collocation method, we know very well 0 to 1 or dx equal to 0 minus 12a1 x squared plus 500 x squared into dx equal to 0 minus 12a1 into x squared. We will integrate means x power n equal to x power n plus 1 by n plus 1 x cube by 3 plus 500 x cube by 3 0 to 1 equal to 0 minus 12 by 3 equal to 1 minus 0 plus by 500 by 3 equal to 1 minus 0 equal to 0 minus 12a1 by 3 plus 500 by 3 equal to 0 minus 12a1 plus 500 equal to 0 plus denominator in 3 it will go other side. After equal means it will get 0, then again we'll say minus 12a1 plus 500 equal to 0 minus 12a1 equal to minus 500 a1 equal to 500 by 12. We'll say a1 is equal to 41.66. Okay, again least square method, I is equal to 0 to integral over the domain 0 to 1 r square dx. So dou I by dou a1 equal to integral over the domain 0 to 1 r into dou r by dou a1 dx. So from that we are minus 12a1 x squared plus 500 x squared. Dou r by dou a1 will get minus 12 x squared because 500 x squared no a1 times. So it should be totally 0. So dou I by dou a1 equal to 0. We need to prove it. minus 12a1 x squared plus 500 x squared into minus 1x squared 0 to 1 equal to 0, 0 to 1, we can say 144 a1 x power 4 minus 600 x power 4 dx equal to 0, 144 a1 x power 5 by 5 0 to 1 minus 6000 x power 5 by 5 0 to 1 equal to 0, 144 a1 by 5 equal to 6000 by 5 will get A1 41.66. So Galerkin method 0 to 1 Wi or dx equal to 0. There is trial function y is equal to W. We know Galerkin method trial function itself being function. So Wi or dx equal to 0 integral over Wi or dx 0. Instead of Wi we need to put trial function A1 x minus x power 4. So a1 x minus x power 4 minus 12 a1 x squared plus 500 x squared dx equal to 0. We need to take a1 is outside x minus x power 4 minus 12 a1 x squared plus 500 x squared dx equal to 0. So integrating x power sorry multiplying x minus x power 4 into inside, so we'll get minus 12a1 x power 4 by 4 plus 500 x power 4 by 4 plus 12a1 x1 x power 7 by 7 minus 500 x power 7 by 7, limit 0 to 1. So we are getting a1 is 41.66. Okay, this is the basic problem. Okay, next problem same like that. D squared will be dx squared plus 500 x squared equal to 0, 0 to less than or equal to x less than or equal to 1. The equation is a1 x power x minus cube plus a2 x minus x power 5. Okay, the unknown parameters here to up to now two, one unknown problem is unknown element is found. Now here two unknown parameter. Okay, the same how we are using means see here first point location. Just I will give overall view. 0 first, what is the limit? 0 to 1 by 0 to 1, 0 to 1 by 2 we are taking one equation, x equal to 1 by 3 we are getting one equation. So make again 1 by 2 to 1 we are getting one value, 2 by 3, 1 by 3 is how much? Anybody can you say 1 by 3 value is what? The value of 1 by 3?
0.33 sir.
1 by 3, 0.33. So 0 to 0.5 we are getting 1 by 3. So 0.33. Substitute the values, we'll get the equations. Then again 1 by 2 to 1. So we are getting the value a2 equal to 25, a1 equal to 18 by 0.3. So a1 x minus x cube plus a2 x minus x power 5. Substitute a1 and a2 values. This is called point collocation. Okay. Next, subdomain collocation. This method requires 0 to 1 or dx equal to 0. The interval 0 to 1 is divided into two domains, 0 to 1 by 2, then again 1 by 2 to 1, because two unknown means the we need to split the domain into two. One is 0 to 1 by 2, another one is 1 by 2 to 1, because the given limit is 0 to 1. So for domain 1, integral over the domain 0 to 1 by 2 or dx equal to 0. We know very well r is minus 6a1x minus 20a2 x cube plus 500 x squared dx. So we need to integrate x squared by 2, x cube x power 4 by 4, x cube x power sorry x squared x cube by 3. We need to integrate. We have substitute the limit 0 to 1 by 2. Upper limit is 1 by 2. Lower limit is 0. We'll finally get the equation a1 plus 0.4166 a2 equal to 27.773. For domain 2, the limit is upper limit is 1, lower limit is 1 by 2, because our limit is 0 to 1. So split means 0 to 1 by 2. For first domain, 0 to 1 by 2. 0 is upper as a lower limit, 1 by 2 is upper limit. For the second domain, 1 by 2 to 1. 1 by 2 is lower limit, 1 is upper limit. Minus 6a1x minus 28x cube plus 500x squared dx. So we need to integrate minus 6a1x x squared by 2, 1 by 2 to 1, minus 20a2 x power 4 by 4, 1 by 2 to 1, plus 500x cube by 3, 1 by 2 to 1 equal to 0. So we'll get equation a1 plus 2.083, a2 equal to 64.813. So a1, a2 We need to solve the equations. We are getting A1 is equal to 18.50, A2 equal to 22.23. This is called subdomain collocation method. So we can say y equal to 18.50 x minus x cube plus 22.23 x power minus x power 5 by x minus x power 5. Then third one is least square method. This method we know very well. I is equal to integral over r square dx. Integral over the domain r square dx. So 0 to 1. Same like that. We here also two unknown parameters a1, a2. So dou I by dou a1 equal to 0 to 1 or dou r by dou a1 dx. Then again 0 to 1 by 2 or dou r by dou n dx minus 6a1x plus minus 20a2x cube plus 500 square. So we need to differentiate residue over with respect to a1. So dou r by dou a1 equal to minus 6x. So substitute r and dou r by dou a1 values in that dou I by dou a1 equations. So dou I by dou a1 equal to partial differentiation. Dou I by dou a1 equal to 0 to 1 by 2 because first of is 0 to 1 by 2. First domain is minus 6a1x minus 28x cube plus 500x squared into dou r by dou a1 is minus 6x into dx. So dou I by dou a1 equal to 0. We are getting the equation a1 plus 0.5 a2 equal to 31.25. For domain 2, our limit is 1 by 2 to 1. Okay, dou I by dou a2 equal to 1 by 2 to 1. In book, the given is wrong. 1 by 2 to 1 r into dou r by dou a2 dx. So r is minus 6a1x minus 28x cube plus 500x square. Dou r by dou a2 equal to minus 20x cube. So dou I by dou a2 equal to 1 by 2 to 1 minus 6a1 minus 28x cube minus 500x plus 500x square into minus 20x cube. So dou I by dou equal to 1 by 2 to 1 minus 6a1x minus 28x2 plus 500x square into minus 20x cube equal to 0. 120 a1 x power 4 plus 400 a2 x power 6 minus 1000 10,000 x power 5 equal to 0. So from this equation we are getting a1 plus 2.438 a2 equal to 70.564. Just zoom it, you will get all those things very clearly. Don't sit simply, just zoom it, you can get all those things. Okay. So solving these two equation, we are getting a1 equal to 21.11, a2 equal to 20.28. So trial function y is equal to 21.11 x minus x cube plus 20.28 x minus x power 5. So Gaussian method 0 to 1 wi or dx equal to 0. So wi equal to trial function y x minus x cube. So x minus x cube, because we need to use two domain. First is a1 x minus x cube plus a2 x minus x power 5. X minus x cube for a1 finding a1, that is domain 1. X minus x 5 for finding a2, that is called domain 2. So we need to Galerkin method is somewhat different method because here 0 to 1 by 2 w1 or dx. What is weighing function 1 for unknown parameter a1? What is the function, trial function x minus x cube only? Don't consider x minus x power 5 because the weighing function 1 should be equal to trial function 1 for unknown parameter a1, that is for domain 1, that limit is 0 to 1 by 2. Okay, so substitute wi y equal to x minus x cube into a1 or minus 6a1x minus 28x cube plus 500x square dx. So multiply x minus x cube into this equation, will get minus 6a1 equal into x cube by 3 0 to 1 by 2 minus 20a2 x power 5 by 5 0 to 1 by 2 plus 500 x power 4 by 4 0 to 1 by 2 plus 6a1 x power 5 by 5 0 to 1 by 2 28 x power 7 by 7 0 to 1 by 2 minus 500 x 6 by 6 0 to 1 by 2 equal to 0. So solving this equation, finally we are getting a1 plus 0.4832 A2 equal to 30.651. For domain 2, 1 by 2 to 1, W2 or dx. Here the trial function is W2 into x minus x power 5. R is minus 6a1x plus minus 20a2x cube plus 500x squared. So solving this, we are getting for domain 2, a1 plus 1.843a2 61.035. So A1 minus 0.4832 A2 minus 30.651 equal, that is equation 1. A1 plus 1.843 A2 equal to 61.035. This is equation 2. So solving this, 1.3598 A2 equal to 30.384. A2 is equal to, we can say, 22.34. So A2 22.34 means substitute this value in the first equation, will get A1 equal to 19.862. So out of these four methods, the result, what is the trial function? Y is equal to A1 into x minus x cube plus A2 into x minus x power 5. So by using point location method, A1 equal to 18.53, A2 equal to 25. By using subdomain collocation method, A1 equal to 18.50, A2 equal to 22.23. By using least square method, A1 equal to 21.11, A2 equal to 20.28. By using Galerkin method, A1 equal to 19.68 to A2 equal to 22.34. So comparing all other problems, this problem is somewhat different because by using two unknown parameters, the values are different. A1, A2 values are different by using different methods. But in before problems, all the value A1, A2 values were same for by using all the methods. So this is somewhat different problem, but they will not ask all the methods. You need to use any one method. By using that, we need to find both unknown parameters A1 and A2. Okay. The next problem is the following differential equation is available for physical phenomenon. That given differential equation is d squared I by dx squared minus 10x squared equal to 5. The limit is 0 to 0 less than or equal to x less than or equal to 1. The boundary conditions are y of 0 equal to 0, y of 1 equal to 0. By using Galerkin method of weighted residual. Listen carefully. By using Galerkin method of weighted residuals to find an approximate solution of the above differential equation and compute with each exact solution. So the differential equation is d squared by dx squared minus 10x squared equal to 5. So in this problem, one thing is not given. Can anybody say what is not given? Venkatramana, Augustine Thomas, anybody can you say which one is not given in this problem? D squared by dx squared minus 10x squared equal to 5, 0 less than or equal to x less than or equal to 1. The boundary conditions are y of 0 equal to 0, y of 1 equal to 0. We need to follow Galerkin method, wi or dx equal to 0, integral over the domain. What we are going to use? Wi equal to what? In Galerkin method, anybody?
Why, yeah, sir.
Y. It's given or
Trial
not here?
function.
In this problem, trial function is given or not?
sir.
No. How will you solve? How will you solve without giving trial function? How will you solve? We need to assume trial function. By based on boundary conditions, we need to d squared by x squared minus 10x squared equal to 5. In this trial function is not given. So boundary condition is y of 0 equal to 0, y of 1 equal to 0. Anybody can you say how will you assume trial function? Anybody? Can you judge? How will you assume trial function? Anybody will you say now? See the problem. Y equal to a1 x into x minus 1 they are assuming. How anybody can you say? Augustine, are you there? Okay, he also don't know anything. I think
By
the
help of boundary condition, sir.
yeah, Abhinesh, tell me, man.
Sir, with the help of boundary conditions, sir. They give a
Yes,
boundary
very good,
conditions.
very good. The format is A1. How many parameters we need to check? One parameter. Single trial function means only one constant A1x into x. The boundary the limit is up to 1 only. That means x minus 1. That limit is 10 means x minus 10. The limit is 5 means x minus 5 like that. So the given condition is 0 less than or equal to x less than or equal to 1. The limit is y of 0 equal to 0. That means x equal to 0 means y equal to 0. Y of 1 equal to 0. X equal to 1 means y equal to 0. Okay. So substitute that values a1x into x minus 1 because why we are going to keep 1 means the boundary condition the limit is up to 1. So a1x into x minus 1. So substitute the values check it the boundary condition it satisfies or not. X equal to 0 y equal to 0. Check it put x value is 0 it
Yes, sir.
satisfies or not. Okay, right. Check it x equal to 1
Yes, sir.
a1x into x minus 1. Okay, so it satisfies the preconditions. So this is called as trial function. So dy by dx a1 x squared minus x it's their equation. Dy by dx a1 into 2x minus 1 d squared I by dx squared equal to a1 2x is 2 1 is 0. So d squared I by dx squared equal to 2a1. What is residue? D squared by x dx squared minus 10x squared equal to 5. D squared by dx squared is nothing but 2a1 r equal to 2a1 minus 10x squared minus 5. So what is Hamilton method? Integral over the domain 0 to 1 wi r dx equal to 0. Wi equal to a1x into x minus 1. So 2a1 minus 10x squared minus 5 dx. So take the common term a1 constant in outside. 2a1 minus 10x squared minus 5 into x squared minus x. Multiply this will get a1 0 to 1 2a1 x squared minus 10x power 4 minus 5x squared minus 2a1 x plus 10x plus 5x dx. This is fully mathematic oriented. Okay, listen carefully. Integration is very very important. 2a1 x cubed by 3 0 to 1 minus 10 x power 5 by 5 0 to 1 5 x cubed by 3 0 to 1 minus 2a1 x squared by 2 0 to 1 plus 10 x power 4 by 4 0 to 1 plus 5 x squared by 2 0 to 1 equal to 0. 2a1 by 3 equal to into 1 minus 0 minus 10 by 5 into 1 minus 0 minus 5 by 3 into 1 minus 0 upper limit minus lower limit 2a1 by 2 1 minus 0 10 by 4 1 minus 0 plus 5 by 2 1 minus 0 equal to 0. 2a1 by 3 minus 2 minus 1.666 minus a1 plus 2.5 plus 2.5 equal to 0. 0.666 a1 minus a1 plus 1.334 equal to 0. So we can say 1.334 0.666 a1 minus a1 will get minus 3 0.334 a1. This 1.334 will go that side means will say minus 1.334 a1 equal to 4. So final equation is 1. So compare these equations d squared by 10x given. So C2, this is common integration. We know very well. Compare this normal equation means directly we can integrate. We'll get the same answers. So approximate solution is y is equal to 4x into x minus 1. The exact solution is 0.883 x power 4 plus 2.5 x squared minus 3.333 x. Just note down exact because we know approximate method how to do Galerkin method. This only just copy it exact solution. Just 2 minutes. Copy it. We'll move. Okay, I think we completed d squared by dx squared plus equal to 10x squared plus 5. We need to differentiate first, integrate it, then we'll get the values C1, C2 values, the substitute that equation will get final solutions. Okay, the next problem is this one. D squared by the differential equation of a physical phenomenon is given by d squared by dx squared plus y equal to 4x. 0 less than or equal to x less than or equal to 1. The boundary conditions are y of 0 equal to 0, y of 1 equal to 1. Obtain the term approximate solution by using Galerkin method of weighted residual. D squared by dx squared plus y equal to 4x, 0 less than or equal to x less than or equal to 1. Okay, y of a1x into x minus 1 plus x. How, see here the boundary conditions. Anyone can you say how they judged this boundary condition, assumed this trial function? Anybody can you say how they assumed this trial function? In this problem also trial function is not given. Just anyone can you say now? Then we'll move the problem clearly. Okay, no one is saying. See the boundary condition y of 0 equal to 0, y of 1 equal to 0. In this equation, see all the problems d squared by dx squared plus y equal to 0, it's there. But here 4x. Okay. So here is given is 4x. So then y of 0 equal to 0, y of n equal to 0. See other problem boundary conditions. The both the equation y of 0 equal to 0, y of 1 equal to 0. Like that it will be there here. Y of 1 equal to 1. The result final answer is 1. How it will occur 1? Anybody can you say now? No one. Y of 1 equal to 1. In before problems like this came,
Yeah, zero
no, y of 1 equal to 0,
plus
y
one
of
we plus we
0.
can.
Like that, y of 1 equal to 1 here given. So for that purpose, we are adding plus x. A1x into x minus 1. How it came? Y x minus 1 means the maximum limit is 1. So x minus 1 plus x y occur means y of 1 equal to 1. So one value we need to get. So for that purpose, we are taking plus x. Okay. So substitute the boundary condition y of equal 0 equal to 0, x equal to 0, y equal to 0. Definitely we are getting same x equal to 1, y equal to 1. The second boundary conditions also satisfies. For that purpose, we are adding plus x. Okay, anybody having doubt with this? Anybody having doubt with this? Anybody having doubt with this? Okay, I think no doubt.
No, sir.
Solve this. Y equal to a1x, x minus 1 plus x. Okay, we'll get a x into x, x square minus x plus x. So differentiate dy by dx. A1, 2x minus 1 plus 1, d squared by dx squared, a1 into 2. So 2a1. That is squared by dx squared value equal to a1 plus y equal to 4x. This is called residue. Okay, y is what? Trial function a1x into x minus 1 plus x. So finally the residue is 2a1 plus a1x into x minus 1 plus x in minus 4x. Okay, so we know very well Galerkin method. Integral over the domain wi r dx equal to 0. So y w x into x minus 1. So 0 to 1 x into x minus 1, 2a1 plus a1 into x into x minus 1 plus x minus 4x dx equal to 0. We are integrating we are getting 2a 1 x squared integration x cube by 3 0 to 1 upper is 1 lower is 0 plus a1 x power 4 x power 5 by 5 upper is 0 lower is sorry, upper is 1 lower is 0 minus a1 x cube integration is x power 4 by 4 0 to 1 minus 3 x cube x power 4 by 4 0 to 1 minus 2a1 x squared by 2 0 to 1 plus a1 x cube x power 4 by 4 0 to 1 plus a1 x cube by 3 0 to 1 plus 3 x cube by 3 0 to 1 equal to 0. We are getting 2a1 by 3 plus a1 by 5 minus a1 by 4 minus 3 by 4 minus 2a1 by 2 minus a1 by 4 plus a1 by 3 plus 3 by 3 equal to 0. So 0.666 a1 plus 0.2 a1 minus 0.25 a1 minus 0.75 minus a1 minus 0.25 a1 plus 0.333 a1 plus 1 equal to 0 minus 0.301 a1 equal to minus 0.25 a1 equal to 0.830. So y is equal to 0.830x into x minus 1 plus x. So 0.830 x squared minus 0.830 x plus x. We are finally the solution is y equal to 0.830 x squared plus 0.17 x. Okay, this the next problem is very very important. This is called application oriented problem. Just note down this question. Find the deflection at the center of simply supported beam of span length L subjected to uniform distributed load throughout its length as shown in the figure using point collocation, subdomain collocation, least square and Galerkin method. Just drop the diagram and write the problem. It's very important. Deflection at the center by using point collocation, subdomain and least square and Galerkin. The problem is very important. Just note down the problem. Just note down it. Are you completed? Are you there?
Wait, sir.
Okay. See here. Okay. The differential equation, how will you form for simply supported beam means dEI d power 4I by dx power 4 minus W, small w, intensity of loading equal to 0, 0 less than or equal to x less than or equal to 1. This is the common differential equation for simply supported beam carrying UDL load at the center. This is a UDL load or throughout the beam. Okay. So the boundary conditions are y equal to 0. See here very well. A point y equal to 0, x equal to 0. Is it correct or not, man? Y equal to 0 at x equal to 0. Next, this in B point at x equal to L, y equal to 0. Is it correct or not? Y is nothing but displacement, man. Displacement is 0 at A and B point. Displacement is 0 at A and B point. So x equal to 0 in initial, x equal to L at end point. Is it correct or not? X equal to
Yes,
0
sir.
at initial point, x equal to L at end point. See here, the boundary conditions y equal to 0 at x equal to 0 and x equal to L where y is the deflection. Okay, so E is Young's modulus, I is moment of inertia of the beam. So the given trial function, this is called trigonometric function y equal to A sine pi x by L. The trigonometric function is y equal to a sine pi x by L. Okay, because the simply supported beam problems, the trial function is we need to go with trigonometric a sine pi x by L dy by dx. Can you anybody say what is the differentiation of sine? Sine differentiation is
Cos, sir.
cos. Dy by dx equal to a into sorry, a constant cos sine differentiation cos pi x by L. Again we need to do differentiation of pi x by L, we'll get pi by L. So dy by dx equal to a into cos pi x by L into pi by L. We can write a pi by L into cos pi x by L. Again d squared by dx squared. Anybody can you say? Because d power over 4 by dx power 4, we need to do 4 times differentiation. So d squared by dx squared. Cos we will do differentiation will get means we'll get minus sign. So minus sign pi x by L, a is constant is there constantly, then already pi by L there, again we need to do pi x by L, pi by L will get, so totally pi by L into pi by L, we can say pi squared by L squared. So d squared I by dx squared equal to minus a pi squared by L squared sin pi x by L. Then again we are going to do d cube by dx cube. Sine we will do differentiation means cos. Already minus is there. Again we will need to put minus because minus is there. Continuously it will come minus a pi cube by L cube cos pi x by L. Again d power 4I by dx power 4 cos we will do differentiation will get minus sign, already minus is there, minus into minus plus a into pi power 4 by L power 4 sin pi x by L. So d ei d power 4I by dx power 4 minus small w equal to 0, d power 4 by dx power 4 is a pi power 4 by L power 4 sin pi x by L. Okay, so R residue equal to E I A power 5 power 4 by L power 4 sin pi x by L minus small w. Point collocation method equal to 0. E I A power pi power 4 by L power 4 sin pi x by L equal to my small w. We need to know the limit is x0 to L. So x equal to L by 2. It's a center point. Substitute x equal to L by 2 will get A equal to WL power 4 by pi power 4 EA. So sin pi by 2 equal to 1 here because x by 2, x value is L by 2. Will get LL cancel. Finally, pi power 4 by L power 4. Sin pi by 2 is called 1. Okay. Just note down up to point collocation method. Then where the maximum value occur in center point, where maximum deflection occur at the center. So equation is y equal to a sin pi x by L trial function. A is WL power 4 by pi power 4 EA. So WL power 4 by pi power 4 EA sin pi x by L x equal to L by 2. Substitute the value, will get y maximum equal to WL power 4 by pi power 4 EI. Okay, just note down.
Sir, here we find the rate of loading, sir. Loading rate, sir. D power 4.
Abhinesh, Abhinesh, are you there?
Yes, sir.
Your question
Sir.
is we need to find the deflection. Read the question first. Find the deflection at the center, simply supported beam. Deflection, the simple of the word deflection is y. Okay, y is trial function for us. A sin pi x by L. Okay, that a in that deflection which is unknown a by using four methods we need to find. That's all. Okay. So what ultimate aim is we need to find deflection that is called y. In that unknown is a. Okay.
Okay, sir.
Okay, now we are getting maximum deflection y max. So substitute x equal to L by 2. Center point only will get maximum deflection. Y max equal to WL power 4 by 97.4 EI. EI we know very well flexural rigidity because it's a beam, simply supported beam. Okay, are you completed? Are you completed the problem? Point collocation is over. Now subdomain collocation. We know very well subdomain collocation integral over the domain or dx equal to 0 or residue. We know very well. EA a power a into pi power 4 by L power 4 sin pi x by L minus small w. So here integral over the 0 to 1 or dx equal to 0 or is a EI pi power 4 by L power 4 sin pi x by L by minus small w into dx. So we know very well very well integration. Sine integration is sin pi x by L. Integration we will get sin integration minus cos pi x by L. Again we need to integrate pi x by L term. We'll get pi by L. We need to put that in denominator. So a e power pi power 4 L by pi power 4 by L power 4 sin pi x by L minus W into dx equal to 0. While doing integration, a e I pi power 4 by L power 4 is constant. Sin pi x, because we are respect to x, we are integrating sin pi x by L, we are integrating minus cos pi x by L. Again pi x by L, we are going to integrate, we'll get pi by L. Okay, minus W into dx. X integration is x. Okay, wx 0 to 1, upper limit is 1, lower limit is 0. So a pi power 4 by L power 4, pi by L, that constant value, it will come to the numerator means L by pi. We need to multiply with constant term. My remaining term is minus cos pi x by L. Substitute the limit 0 to 1. Then again minus wx, substitute the limit 0 to 1. 0 to, sorry, one, not 1 L, because the limit in the value length of the beam is 0 to L. Initial point a point 0, x equal to 0, end point is L. We know very well. X equal to 0, y equal to 0, x equal to L, y equal to 0. In center point we have deflection. We are going to find that only. We know very well. Then a pi power 4 by L power 4 minus cos pi x by, minus will take commonly out, cos pi x by L. Substitute the limit 0 to L, cos pi L by L. LL cancel, cos pi minus cos 0 minus W L minus 0 WL, we can say cos pi value we know very well, cos pi 2 pi 3 pi 4 pi whatever it may be, minus 1, cos 0 is 0 1. We should remember now for these problems sine and cos values 0 1 by 2 1 by root 2 root 3 by 2 1, that values we need to remember now. Okay, a minus a pi cube by L cube, cos pi minus cos 0 minus WL minus a pi cube by L cube minus 1 equal to WL. Will get a value is WL power 4 by 62 EA. So y equal to WL power 4 by 62 EA sin pi x by L. Substitute where we need, what value which we need to get maximum deflection. Where could occur maximum deflection in the beam? X equal to L by 2. Okay, x equal to L by 2, we are getting maximum deflection. So substitute that trial function y equal to WL power 4 by 62 EI sin pi x by L. X equal to y max equal to WL power 4 by sin pi by 2 into L by 2. Y max equal to WL power 4 by 62 EI. The same concept we need to apply for least square method and Galerkin method. I equal to 0 to L R square dx is minimum. In that we are getting a value same. Anybody having doubt with this, just listen and check it and tell me the differentiation and integration. If you have doubt, inform me. I will be here. Once again, I will repeat the option is Ilango came and out. But what I need to do, I don't know. He is not informing, sir. I am present like that. Arulselo absent. Ilango absent. Manoj M. He came present. Navin Kumar D is absent. Vignesh P is absent. Sridhar M is present, absent. He told mobile problem. Who is present?
Sir, Navin Kumar D.
Okay. Why you came late, man?
Sir, நான் first வந்து உள்ளே தான் இருக்கேன்.
Then last time also he told absent, but you didn't respond me. Now you are saying